We're continuing on with the zero product law. I don't know how much of a law this is. Sometimes books will call these properties. Zero product property, which is kind of fun to discuss. But anyway, you're probably familiar with this from a long time ago, is as long as one of the two numbers is equal to 0, the product of those two numbers must be 0. Which makes perfect sense. Like as I get to this first exercise, when you look at x plus 7, if that quantity were equal to 0, I would not care about this other number. So if you subtract the 7 over, to cancel out the 7, 0 minus 7 is negative 7. So let's talk about that for a second. If x were negative 7 plus 7 is 0, and negative 7 minus 3 would be negative 10, and 0 times negative 10 is still 0. Same thing with the right side. If x minus 3 were equal to 0, and you add 3 over, then you would get x equals 3. So if you're looking at that, then it would be, I'll write it up here, 3 plus 7 is 10, and 3 minus 3 is 0, and 10 times 0 is still 0. So that's how we're going to use this to identify zeros or solutions. So I could do the same thing on the next one. Either 2x minus 5 equals 0. So you could add 5 over. 0 plus 5 is 5. And then as you divide by 2, just leave it as an improper fraction. But you might also notice a shortcut here that it's always the opposite of these numbers. So x equals 4, but you have to be careful about dividing by that coefficient, which is what happened on the previous one. If you don't believe me that it's always the opposite, just add the 4 over, and you could confirm that, yeah, x was equal to 4. And then, yeah, big deal that there's a times 4 in front. What I'm really concerned about is if 3x plus 2 equals 0, or 4x minus 3 equals 0. And again, I'm trusting that you'll figure this out, the sooner the better, that you would subtract 2 over and divide by 3. Same thing with this one. You would add the 3 over, but then you'd have to divide by 4. So you can double check that all of my answers are correct as well, because you could plug it back in. So in 1C, why does the factor of 4 have no effect on the solution set? Well, 4 times 0 is still 0. Multiplying by 4 does not change anything. So that's why the multiplying by 4 has no effect. Is the only way to get 0 is if 4 times 0 equals 0. The times 4 has no bearing on what happens. So how can we use this? We're going to be factoring again. But what's super important is if you're going to use the zero product law like we are, it has to equal 0 first. So you don't have to do the problem the way I'm doing it. There's other ways of doing this problem, I should say, but it's easiest if you just get one side equal to 0. Now you don't have to get this side equal to 0, but I would suggest it because I like to have x squared be a positive term. Just combining like terms, and then from here I can quickly identify that factors of negative 24 that add to be 5 are 8 and 3. Just make sure that the 3 is negative. And please show the work until you get really good at this, because I have a lot of students who will write down that the answers are 8 and negative 3. No, those are the factors. So either x plus 8 is equal to 0, so you'd subtract the 8 over, or x minus 3 equals 0, so you'd have to add the 3 over. And you can double check that these answers are right. If you use a calculator, you could just plug them all in, or this wouldn't be bad just to plug in 3 in for all of these x's. So just to quickly show you, 3 squared is 9, 3 times 3 is also 9. So we're at 18 minus 14 is 4, and then plugging into the other piece, negative 2 times 3 is negative 6, and when I add 10 to that I get 4. So I did get the same answer on both sides, but my work there in red is just checking my work. you don't have to check your every answer. You could see that -8 also works in that equation. So as I move on to the letter B, again, my suggestion is just to get it equal to 0. And you don't have to do the problem my way, but I would subtract x squared to the left side. So that would be 2x squared. I would subtract 3x to the left side. And my whole goal is to get things to equal 0. So then add 2 to the left side. So the right side is now equal to 0, and we're at -5. And you get to choose how you would want to factor this. If if you did the AC method, and then you would have factors of 10 would be 10 and -1. But if I were doing this problem, I would just guess and check. Because there's only one way to get 2x squared. There's only one way to get 5. But as I FOIL this out, it would be a positive 10x minus 1x is 9x. And as you get really good at this, I should still equal 0. And you add 1 and divide by 2. And then this other answer is just subtract 5 over. So those are your two answers. Okay, feel free to write down your questions and bring them to class. So the other piece of this is that we could actually find the intersection points of these algebraically, but then we can also look at what it means for a graph, and we'll use a graphing calculator. So if I asked you to do these two problems with intersection points, that means they have to be equal to each other. So that's what I'm going to do first. I'm just going to set them equal to each other. And the reason why that would be to your benefit is then you could just subtract 4x over. And you could also subtract 5 over. Well, that's kind of nice. All those 5's will cancel. On the right side, you have 0. On the left side, you'd have 3x squared minus 12x. So from here, what I would do is just the greatest common factor. Greatest common factor is 3x, and you're left with x minus 4. So based off of this problem, we have either x is equal to 0. I guess you could write 3x equals 0, but just like in 1c, we don't have to concern ourselves with 3 because that's only true if x equals 0. And then same thing with x minus 4 equals 0. That's only true if x equals 4. So as far as intersection points, I want the x and y coordinate. So one solution is going to be when x is 0, and it's up to you which equation you want to plug into, but it's actually easier if you just do this one, because 4 times 0 is 0 plus 5 is 5. And then plug in 4 in for x. So if I plug in 4 in for x, 4 times 4 is 16 plus 5 is 21. So these are your two intersection points. And yes, there are two of them. So in my graphing calculator, all I'm going to do is hit the y equals button and type in the equations. So it's 3x squared minus 8x plus 5. And then I hit enter or the down arrow and then 4x plus 5. And if you read through the directions, they want you to sketch the graph of the system on these axes. So in order to sketch the graph, you have to type it into y equals first, and then go to the graph. And unfortunately, we can't quite see everything. And the reason why we can't see everything is my window is in the normal -10 to 10. But remember, we said that they intersect each other all the way up at y is 21. So maybe change your y max to be 25. And so now when I look at this, I do see the points of intersection. And if you look closely, it appears to be 0, 5, and 4, 21. And it might be a while since we've done this to think about why the y-intercept is at that ordered pair. But remember, I guess I'm really exaggerating this y equals 4x plus 5. That we have a y-intercept of 5 and a slope of up 4, right 1. So it looks something like that. And then the other graph, I'll do this. Parabola is the name of that curve. It dips down, and then comes back up. And right now, all I'm concerned about is that the points that they intersect each other were at 0, 5, and all the way over here at 4, 21. I'm sorry that my graph is not very good. So it talks about labeling the curves with equations, the intersection points, and the window. Because that's what I like about the graphing calculators, let me point it out, is they show up as blue and red, which matches the blue and red color from y equals. So if I go back to the graph, I'm going to use the intersect command. That is hitting second trace and the fifth option down, or you can just hit the number 5. Now be careful, this is not necessarily the intersection point. It happens to be because it just puts a cursor right in the middle. What you have to do is hit enter on the blue curve, enter on the red curve, and then your best estimate. And as I already know that the intersection point is 0, 5. So that was the correct answer. But your calculator will only do one point at a time. So second trace, your fifth option down again. But now you have to move the cursor over to the other point of intersection and hit enter for the blue curve, the red curve, and then a third time, and you see it confirms our answer that we did this correctly. So I'm just going to put a quick check mark on here. And yeah, the zero product law is extremely important in finding zeros or X intercepts. So that's what we're going to move on to next. So we have a parabola right in front of you. And if you just look at the graph, you can tell that the X intercepts are -1 and 3. Well, how you figure that out is because those are the ordered pairs -1, 0, and over here is 3, 0. Notice that the X intercepts happen when y equals 0. So in order to solve this, you want to set the equation equal to 0, and then you can use the zero product property. Factor this. Factors of 3 that add to be -2, -3, and +1. So algebraically, you would write it in factored form y minus 3, y plus 1. Not y, I'm sorry, x. I talked about y equals 0 and then I stumped myself. Anyway, look at those answers. They are the opposite, +3 and -1. So we use this zeros are finding the X intercepts. So now we can find the X intercepts of any parabola as long as we're familiar with factoring. So again, we can just set this equal to 0. That's a difference of squares. So it would be 2x times 2x gives me 4x squared. 1 times 1 gives me 1. Make 1 plus, make 1 minus. And so as you work through this, you'll see add 1 over and divide by 2. Subtract 1 over and divide by 2. That's how you get your X intercepts. This next one's a little bit trickier because you might need to do 3 times -10 is -30. Factors of -30 that add to be 13 would be 15 minus 2. So you have to think about how to get 15. That would be 3x times 5 for your outside term, and then 1x times -2. And so using your zero product property, I forgot to write equals 0 up there. Maybe I'll do that right now. Would be x equals add the 2 over and divide by 3, and then on the other one just subtract 5 over. So those are the locations of your X intercepts. And then this last one, I don't know if it's stumping anybody, but your greatest common factor, that's all you have on this one, a GCF, and that would be 5x, and factoring out the 5 makes that x minus 2. So your zero product property would say, hey, we have an X-intercept at 0, but then also at 2. And now you're ready for the homework.